There it is. Professor Emeritus Dr. Yrjo Roos is affiliated with the School of Food and Nutritional Sciences, University College Cork in Ireland. He holds a Master in Science, PhD, and Doctor in Science awards from the University of Helsinki in Finland. Following an early industrial career in the dairy industry, he joined the Department of Food Science at Rutgers at the University State of New Jersey in the US in 1989. In 1991, he returned to the University of Helsinki as professor and senior research fellow of the Academy of Finland. He was appointed as professor of food technology at the University College Cork in 1999, where he also served as head and dean. His main research interests are in dairy and in food processing technologies and food material science. He is president of the Central Committee of International Symposium of Water in Foods, the ISFE, and founding member and chair of the European Academy of Food Engineering. He has H-index of 72 for numerous research publications and books with more than 23,000 citations. He's the recipient of the International Association of Engineering and Food Lifetime Achievement Award, the Swiss Thermal Analytical Society Award, and the ASADE International Food Engineering Award. He is fellow of the IFT and IFOST. He has served as member of the EFSA Working Group and Panel for Food Enzymes since 2021. Now, before we start, please remember to mute your microphone during the presentation. If you have any questions through it, you can either write them in the chat so that you do not forget them. At the end, you can directly ask them to the speaker, or I can also read them aloud for you. Again, thank you everybody for being here, and thank you, Professor Roos, for accepting being our today's speaker. It's very great to have you. Thanks.
Thank you very much. Can you hear me? I hope so. So, and thank you for a beautiful introduction. It's really my pleasure to be here this afternoon or morning, whatever time you have, as an invited speaker for the 2025 webinar series of the ISFE, IFOS, the Tecnología de Monterrey. And really, I like to give my thanks, special thanks to Viridiana Teixeira and Professor Jorge Welty, making this possible and giving me this opportunity. I like to talk about food processing and processed food classification, which is something I have been recently involved in to different arenas. So, we couldn't move my slide. So here we go. First of all, I like to point out a few things on food processing itself, just to take ourselves into the context that I like to address today. So my view here on healthy, sustainable, and diverse food system gives some ideas about food processing and how I see it. I would think, firstly, that we are looking into like a dotted line box here with no real borders, but we can identify their food production, whether being agriculture, that as we see agriculture as a traditional way or even new ways of producing foods. There's a lot of going on in that sort of things using various new avenues. So anyhow, there we need diversity. We need different types of foods coming to the food industry and go through the whole chain towards someone eating it, using it, and then having most likely and hopefully healthy life. But then the cycle continues towards processing back, diversity, sustainability, and continues. But the processing that we address today is pretty much shown by the different arrows on this diagram, the blue arrows that can go differently to different steps or different arenas of processing where it happens in the industry, in the food service, in retail, in home preparation or home cooking, and until the consumer or your person eats the food and it goes through additional processing in the body. So here we can then start to think about the role of food processing overall in terms of the consumer well-being, which has been quite a lot looked at in recent times. But I would emphasize that what I think is there is too much confusion, a lot of confusion that has been created on the area of food processing. And I think there is not really good understanding always on the meaning of food processing. What is included there? And also the meaning of processed food is not always clear. It's kind of gray to many people who talk about these matters. And then we have classifications, either food processing or the processed food, and this confused, and then classification, way of classifying things. There's confusion on whether it's nominal or ordinal. So there's some disorder. And that's why I have paid attention to those. And we can have a look what is one of the issues. I have shown here some of the papers that come from Monteiro Group since 2009, who actually are those who created some of the confusion, I think, because the original paper here on the left top is showing a title, Nutrition and Health. The issue is not food nor nutrients so much as processing. And then that has continued. If you look at the next one on the right, food classification systems based on food processing, significance and implications for policies and actions, a systematic literature review and assessment. What I have found is that if we think about the contents of these papers, they don't really give attention to food processing, although it's not the title. They talk about processed food. Then if we look at the lower ones there, they are a couple of other papers. On the left, there's a title, Is the Degree of Food Processing and Convenience Linked with the Nutritional Quality of Foods Purchased by US Households? And on the right, another related title, Characterization of the Degree of Food Processing in Relation with its Health Potential and Effects. They mention degree of processing or sometimes level of processing. But if we again look at the contents of these papers or chapters, we may make the conclusion then that there's not really any degree of food processing defined. So they have something that is confusing, that the level of food processing may have something to do with health. And it has culminated to something recently shown here, associations between degree of food processing and all cause and cause-specific mortality, a multi-center prospective cohort analysis in 9 European countries. Again, the degree of food processing. Of course, I would agree if they jump into a mill and go through and get mortality, but they don't do that. What is here the topic is higher UPF, referring to ultra-processed food consumption was associated with greater mortality. So this implies that the food processing causes mortality. And I think that is not really the right wordings that have been used. So I like to show some what I think are misconceptions. These misconceptions come after the introduction of the ultra-processed food terminology. So the NOVA concept. And I think many of you are familiar with the NOVA grouping of foods. What can make sense, perhaps, is what we see there on the top left, bunch of or tray of different type of food products coming from agriculture. Even these can be somewhat processed already, but let's say we can call them unprocessed. That's not a problem. But if we look at then what is following is a number of different ways of looking at the food processing that happens to these foods after. They may go to processes like canning, which is basically shown here that it is processed food. And then the problematic category arises from ingredients and additives put into products in processes, and then it becomes the ultra-processed food. So I think this classification has arbitrary nominal classes that do not really have anything much to do with the processing itself. They are classification of food, like it says. But then why would it be ultra-processed is another topic to consider. Ultra-processed food, according to these definitions, are largely shown here, directly from the papers. And then there is also the present classification of NOVA concept shown in the diagram, showing the 4 classes that are now recognized: minimally processed food, processed culinary ingredients, processed food, and ultra-processed food. And if you look at these, even the pictures there in the circle, we can see that there's a lot of different things put into different categories with not necessarily clear grouping concepts. So the foods anyhow are ultra-processed because they are formulations of ingredients, mostly or exclusively industrial use, that result from a series of industrial processes. And that's the reason they were called ultra-processed. So a problem arises. They are ingredients and not really processed products. And then it continues with sugar, oils, and fats and salt as ingredients. So it doesn't have anything to do with processing as such. So therefore, I think the process shouldn't be a confusing term to a wider audience. Ingredients of no or rare culinary use and additives whose function is to make the product palatable or often hyperpalatable, cosmetic additives. So that is emphasizing something that is added to the food product and not really processing. And then we can see there's a long list of different type of ingredients that have been reported as markers of ultra-processed products, and references to cosmetic additives and so on. So I don't go into more detail about this, but I would like to continue by saying that we do certainly have a lot of foods that have different compositions, and they may contain salt, sugar, and fat because of traditional reasons, many other reasons, especially for safety and preservation. So it's not processing. And if we think about the food additives and processing aids, those are not really processing. They are regulated substances that may be used to make the food safe and also to obtain a consistent product quality. And that's very often important. You may have situations where, for example, in the industry where ingredients come from different sources at different levels of colors and so on. It's seldom the case that we would add colors to make it more attractive. There's also the consistency in question. The same applies to flavor. And the preservative function, of course, is very important. And I also like to emphasize there that we no longer are 200 years ago, where there was problems with colors, lead or chromium or arsenic put into candies and then given to children. That's not the case nowadays. So many of these naturally occurring substances are also listed as food additives, benzoic acid, nitrates, and so on. But emphasis is on this slide that regulations limit uses and it's based on scientific criteria. And then these should not be food processing classification criteria. No way, because they are not associated with processing. And if we strictly look at this thing, we could ask the question, is all industrial food UPF? So maybe something has got the attention of media. Ultra-processed foods make up to 70% of the US supply. How to reduce your intake? So the processing has become, by these media titles, sort of a demonized area, something bad to your health, although usually the intention is opposite. But also the UPF concept has attracted attention by regulators, or let's say guidances, and this is an example of use of the context of the term UPF by World Health Organization, that last summer had a call for experts to develop a WHO guideline on consumption of ultra-processed foods. That is a little bit difficult, I would say, because there are no clear definitions on the UPF. Of course, we can agree, I think, that there are threats and benefits of eating, but we have to eat, otherwise we don't survive. But the threats, if we look at them first, we have immediate, which is toxins, pathogens, viruses, allergens. And then we have long-term effects. Some of those come from pathogens, for example, and also from other reasons like nutritional deficiency diseases, dietary disorders, obesity, non-communicable diseases, cancers, chronic diseases like sepsis, reactive arthritis, etc. Those can happen, and they can happen, for example, like salmonellosis can cause chronic diseases, reactive arthritis as an example, for life. So we really need something that is looking after these factors to be under control. And then benefits of eating are clear. We get energy and nutrients, dietary fiber, probiotics, bacterial bakes, all kinds of good things. And in long term, we would have well-being, healthy body and mind, lower risk of diseases. And the question is, what is the role of processing here? I mentioned a little bit, but I think this is just a little pointing out that main threats reduced are, for example, inappropriate time temperature pressure conditions. If those happen, we may have a threat, failures in GMP and HACCP practices. At the same time, I'd like to highlight that these systems are typically existing in industry, and that means that the threats will be reduced. And then the benefits enhanced by optimal processing parameters are many. Safety, quality, and shelf-life are typical. Nutrition and health aspects are usually improved. Sensory perception is improved, and reduced waste. If we don't do the processing, I think we would have a massive amount of waste in the different households. Also, I like to note here that processing and manufacturing are two different terms, and processing and home cooking are also a little bit different, because strictly speaking, the manufacturing includes formulation, let's say recipes, processing aids, additives, packaging, etc., while processing, I think, is a treatment. So we could, at this point, also look at some regulatory considerations. That is something that may be a bit different in different jurisdictions. I point out here a couple of slides about EU. regulations because that is where I have my background. But I think the regulations are not much different in general. So always the food shall be that it shall not be placed on the market if it's unsafe. That's clear. And food shall be deemed to be unsafe if it's considered to be injurious to health or unfit for human consumption. And also here we can note that whether any food is unsafe regard shall be had to each stage of production, processing, and distribution. So even legislation is saying that processing is under control by legislation and regulations. And also we could note that a specific adverse health effects from a particular food or food category of foods should be considered and considered at the level even to subsequent generations, which is interesting. But the processing and then the question here, a category of food is asking, or actually alerting me to ask, is UPF considered a category of foods here? If it's claimed that UPF is not is causing harm, so what do we do? And also, if we can look at the novel foods regulations, which is referring to anything new onto the market since 97 May, and it includes new or intentionally modified molecular structure, and it also refers to food resulting from a production process, which gives rise to significant changes in the composition or structure of food, affecting its nutritional value, metabolism, or level of undesirable substances. So there are some regulations that even address processing, although here the point on the production process is not clear if it's a production in the manufacturing or if it's original agricultural production. But then what I said earlier, the ultra-processed food is not well defined. And I think, as many publications also have pointed out, that ultra-processed may imply that the food is processed to be on scope. So that means that we are really normally in industry or in food processing using the prefix ultra to highlight something that is scaled at some level. Ultra in food processing is used, for example, to refer to ultra high temperature, ultra low temperature, ultra pasteurization, ultra filtration, ultra rapid freezing. And then if we think about food processing, we need a scale to put the ultra somewhere. And I think it would burn the food, for example, if it's out of the scale. But also the U ultra, like on the lower there, referring to UST treatments, it is to make food safe and also to provide longer shelf life. And it's a well-established technology. So we shouldn't demonize anything with the prefix ultra. So yes, food and processing in these classifications, I have seen that the processing becomes a black box, and we don't necessarily know what comes out. And what I pointed out, that there's a confusion between this processing and the food and the processed food. So I will concentrate later on this. Food processing versus processed food. If I now define a bit better what I mean, whether food processing or the processed food is of concern often remains unclear. So many cases, like the slides earlier I showed, didn't really define well the processing and the processed food. So the distinction was not there. And therefore, there is misunderstanding that food processing may result in adverse health outcomes. That's what I have concluded. Furthermore, the meaning of processing is very general, and in it can vary enormously among foods manufacturers. What does the processing mean? That means here the statement that you could have two different breads and you could have two different types of products. They may have same commercial name, same intention, but they come from very different processing methods, equipment, etc. And that means that they are not similarly processed, but they may have the same meaning. Then an overall context, foods are not ultra processed because the ultra is not really the right place in that term. So don't use UPF. That's my advice. Now, let's look at the classifications a little bit in more detail and what I would propose in that arena. The food classification examples shown here cover what is mainly in present literature coming from different papers and different years. And if we start to look at what is the classification basis, we can find out that these are really nominal classes that don't have any scale. So they have food categories that can be traditional, industrial, prepared, packaged, unprocessed, or processed, unprocessed, processed, not industrial, less processed, unprocessed. So it's just nominal, no scale. And then food categories that are there, yes, they have. And then they have also these highly processed foods and UPF. And then I like to also note that if we look at do they have processing categories? No, but they do claim that these classifications are based on the extent of processing. I don't think that is true exactly. I skipped a little bit earlier IFOS, the paper that is very new, which divides the classification basis to processing and formulation, but still is following the NOVA classification. But then if we think what is there, it is identifying and classifying the processing in two different windows. But processing levels cannot be claimed without processing categories, and that's the conclusion I would say. And I would think myself that a robust classification must become a tool to establish whether food processing per se or chosen food formulation ingredients cause adverse health outcomes. So we have to do something to, besides formulation and the food compositions, say, did processing do something? And therefore, we have to look at food processing classification possibilities. In the literature over the years and different textbooks, we can find different types of classes for processing equipment or processes. We can find extent of or levels definition that could be related to, for example, physical or chemical or thermal and non-thermal, traditional or novel, or energy applied, heat, pressure, radiation, or pressure temperature used, and so on. But I think that these may not be overarching ways to classify. So in food processing classification, I think we need to take into account that one unifying food processing variable for grouping all processes, everything that you do in the industry may not exist. And also we should consider in this that if we do cooking at home, it may be of a higher risk than any industry process, while any processing may be unique. Then the processing level, I think that should indicate whether a process changes physically or chemically the food under observation. So with these statements in mind, I also here a little bit summarize that in processing, at least at minimum, we should consider that processing includes one aspect and formulation another one, and legislation is there as well, building a base or premise for manufacturing or making food to deliver what it's supposed to deliver, nutrients, energy, and so on. Of course, all these have factors that may have some weaknesses or may have some opportunities, but they contribute to structure, performance, properties, and benefits. And there may be some threats and strengths in any of these variables. But if they are optimized, I think we can have a good way of processing. Now, earlier, we had a little note to the Iowa's task force paper and formulation and processing. I had the privilege of sharing this task force early, and at that time, we defined food processing and food formulation. And we gave the definition to food processing as being the treatment of a food material to achieve a desired effect. The formulation we defined as systematic selection of relative quantities of ingredients for a food product. And these are really two different things. And I think we have to keep that in mind. So it provides some tools to make further steps on food classification. I think we can firstly look at food processing level. So what would it mean? It would mean that we can have food processing categorized to different levels. And then we could take into account my words earlier about processed food. And there we have to define the purpose and the criteria for the grouping of processed food. So they are two different things, grouping food as such and grouping food processing. But if we have those properly made, we can do processed food classification by processing level. So then that means that we can have different levels of processing and different extents of processed foods. I like to remind the audience about chemical engineering principles. Some of these come from very early days of the development of these disciplines. But basically, a unit operation involves physical changes. So that means that we have different types of processes, mixing, pumping, blasting, so on. And then unit process includes also biochemical changes and takes into account reaction kinetics. So there we go to fermentations, bleaching, refining, hydrolysis, hydrogenation, synthesis, typical chemical operations or processes. So that in mind, we could think about what do we do in food processing. And I have, for clarity, made 4 different types of processing classes. So here we have unit operations 1, and that would be designed as a food processing level 0. And then I have a number of comments, object, result, typical processes, purpose and conditions, examples. I don't read everything through, but you can have a look at that later when this presentation is available on the YouTube or otherwise. But the objective in unit operations 1 is minor physical change, and the result is retention of natural food characteristics. A little bit stronger is unit operations 2, which has an object to cause a major physical change. And that results in intense physical operation and disintegration of natural cellular structures. Unit processes 1 is quite often general food processing, but minor chemical changes. And the result is physical, chemical, and enzymatic changes as part of food preparation, processing, and traditional fermentation. Then we have the strongest unit of processes too, which is chemical processing. And that means major chemical and compositional changes. And then you can have a look at typical processes. And then also we should, to some extent, take into account the scale of temperatures where this happen. Unit operations one doesn't really often go much to above ambient conditions, but it can go to sub-ambient temperatures. But unit operations two uses up to boiling point temperatures. Then unit processing often applies temperatures higher than 100 degrees, reference being the water at normal pressure. And then we have unit processes too, which can extend to very high temperatures depending on the nature of the material to be processed. We may consider also that the open food is associated with water that limits temperature of the treatment within the material. Now, then the levels, how would we use those? Here, I start again with unprocessed food. I think that's pretty natural. But I point out that all the food can't go to any of these unit operations or unit process steps. We could also keep in mind that open food processing or any processing is not only in one operation or one process, it is a sequence or sets of these that are put together to achieve something. But overall, we can say that the foods can go to these different processes, and the resultant food processing level is dependent on what it has gone through. We need to take into account that food manufacturing and the production processing has formulated compositions, and the formulations have differently processed components, so the ingredients may come from different processing levels. And that's why I have included an FPL4, which is a formulation-based processing category, which means that the final processing includes ingredient from the level 3 or 4. So overall, then we have final processing levels from 0 to 4. It's 5 levels altogether. And if we look at the manufacturing of food, if we can have one single item as a formulation, or we can have how many you like ingredients in formulation that goes to the final processing sequences. And there we can have different FPLs used to obtain a final food or ingredient, whatever is the item manufactured. But we can start to have an idea what is the food processing level. This may not be enough to look at how it's obtained or what does it mean. And therefore, I made this hypothetical processing extent diagram where you can have food processing level from 0 to 4 and what it means if we have a physical or chemical impact. And I think these are not straight lines. They give something like this, hypothetically, that you would have the relative index from 0 to 1 towards the 4. So all those earlier ones that have used food processing or processed food classification terminology or intended to do that, I haven't seen any decision diagram how to do the classification. We have something proposed here, and that is for processing, which is according to the table I showed earlier, and then we can see the levels coming out from the different unit operations or unit processes. And this can be ingredients or it can be products, but the formulation is there. And that means that the formulation is often going back to processing, and it can also go to the food itself. Now, if we consider that food is intended for eating, we can look at what is the food that you eat, what is the processed food intake class. And that is defined by this FPL. But I think it would be much confusing if it was different from the FPL. So that's why this processed food that you eat has a processing index that follows the number 4, classic 0 to 4 concept. Here's one example how we could, for example, look at cereal food using unbleached flour. I say later why. I have here 3 boxes that have low FPL, moderate, and high FPL. And if we start from grain berries, do removal of the skins, we certainly get grain, and I think that's a 0 level processing, and the index, if we eat it, is 0. And then if we take those grains and do the milling, we have the level 1. And then if we do flour and ingredients and do fermentation and baking, we obtain bread, and that would be going through the FPL2, and we get then prepared foods and ingredients. Then we could take flour as well and separate the starch and do the hydrolysis to obtain glucose syrup. We have a chemical process, and that's then giving, if we eat it as a processed food intake level 3. And then the flour ingredients, for example, the glucose syrup can be taken to powder processing, and we get those foods that are processed ingredients foods, or manufactured or fabricated formulations. So this is what I would propose. And also, I mentioned the bleached flour. We can here have the diagram for how flour is milled, or actually how the grain is milled to flour. Then this means that from the farm, there's a large number of unit operations involved before the grain even goes to the milling. And then there a number of operations happen, but they remain at level 1 until the flour is there, whether it's separated to white or whole weight flour. But as soon as we do bleaching, a chemical process, it goes to further processing, and then that may have an impact on the product level as a processed food intake class. So this is summarizing what I was saying about my FPL, PFI concept, and summarizing those. I don't really go through that, but it shows that the FPL, PFI is the same number, but it has a different meaning, because processing level is really processing, and the intake is what we eat. Then I have conclusions, and I have a couple of slides after this. So in conclusion, summarizing what I have said, I would think that food and nutrition professionals need to ensure correct public understanding of food processing. The UPF terminology should be discouraged and not used. Food processing takes place across the full food chain, while formulation, cooking, oral processing, and digestion seem more important to nutritional quality and human health. Food processing classification must be based on clear differences between categories, for example, physical and chemical. Food processing levels were established and combined with formulation of foods for processed food intake classification. And then the health impact, for example, food consumption from various PFI classes should be followed to observe their role in human health and beyond. So that means we should have data. So the next steps, I think, beyond NOVA is some here. taking first ingredients and foods, I think we could say that we can do mathematical operations. Total and average FPL and PFI values of formulations can be calculated. Data for weight average values may not be disclosed for many products, although those would be preferred and may be needed on dry matter basis. So that's a difficult. PFI values of similar products, for example, breads and snacks, can be compared. That's, I think, something we could easily do. But then more importantly, foods, meals, and diets. So we can have weight average overall PFI values. We can calculate them and relate, for example, to health outcomes. And then like the fat, sugar, salt, so on, from various PFI categories can be related to health data. And finally, ordinal scaling of FPL and PFI allows the use of a number of mathematical and statistical tools in research and otherwise. So those are beyond what I have presented. But you can do a simple quiz if you want to on what I have said. This is just the commercial product, ice cream. So you could consider these ingredients, it's a composite food, and then you could decide using the tables and the diagrams what would be the final FPL or PFI. And if you wish, and if you know the composite food structure, you could even do fractional analysis and obtain maybe a weight average value for the FPL and PFI. And this is a table that you could use as a help. So thank you very much. And there is also a couple of references from my research papers that you can have a look for some more thinking. So I thank you very much for the audience, and it was a pleasure to present. And I hope you received some home take messages and something for discuss.
Thank you. Thank you so much, Professor Roos, for this very nice presentation, very clear presentation, and for sharing well this knowledge with us. So let's start with the question and answer portion of the webinar. Remember, you can ask the question directly or write it down in the chat, and I can also read it for you. So questions. If someone writes something in the chat, I can read them for you. Don't worry. Questions, comments. You're receiving a lot of
Yeah, I see there's some questions, but I do not see how they read.
No, they are just congratulating you.
Okay.
No one has questions, don't be shy. Okay. Oh. No. Oh, okay. Veronica, please, could you open your microphone?
Thank you, Dr. Roos, for the presentation. It was very interesting. I mean, I would like to know your perspective. So we know this is happening. We know what you presented is something that will help us out to maybe navigate a little bit more of this and to begin helping people to understand that processed food and ultra processed food and all these terms and the meaning and the actual things that we are doing with processing and reducing, as you said at the beginning, the bad image that processing, the word processing has in foods. How do you see or that we can translate this to the general public? Because as scientists, it might be easier for us to understand it, but now how can we go against the media, basically?
Yeah. How to stop the horse? I don't have any clear answer to that. How can I do that? But of course, we are in something that has advanced quite a lot, and it has been using buzzwords that is easy to sell to the public. So the media has been very happy to get the readers about this. And the processing is always a topic that the audience like to have. Is this good for me? Is this bad for me? It varies and so on. I would think that if we consider what the media is doing, it doesn't keep running on the same horse, so it will change it with time. So I don't think the concept is a long-term thing. It may pop up every now and then, but I would think in the meantime, while this is happening, the media can also take the positive things into account. It depends what sort of research is done and so on, but we certainly know that a lot of good things on food is also coming. All the time we see eat this and eat that, and that's good for you, and so on. So perhaps we can have something on processing that would give an idea that something very new comes out, and if you note this process, it will give much better food. I think some people are aware of that realistically, that if you are eating something raw or something cooked and so on, it's common sense that for some foods it's okay, for some raw foods it's a must, and so on. But I said, I don't see how we immediately change the direction.
Thank you. I think one might think that is true, that the common sense is it's there. But I remember probably like 10 years ago in the US, in California specifically, they were selling raw water. That was the brand, and it was taken from a stream, probably not processed at all. So the possibility of getting ill, it was high, and there was a lot of people buying it just because it was unprocessed. So I have my doubts about the common sense part, but
Well, I take your point, and of course we have different individuals and we have different cultures and so on. So there's certainly always people who don't think and go with the crowd. So someone says that the boat is shifting, and everyone goes to the other side, and then the other side, and so on, without taking a lead. So someone needs the leadership.
thank you very much.
Thanks, Yrjo. Lali, would you like to read your question? Is Lali still here?
I'm still here.
Oh, okay, great. Do you want to read your question?
Yeah, well, thank you for the conference, Doctor. And my question, well, mainly because eating has become some sort of political act. I'm very concerned about like the big companies, that finally sell these kinds of ultra-processed foods. And I would like to know, how can regulation be applied to limit companies from taking advantage of vulnerable populations that, like, if they're not careful, they could have the opposite effect, like malnutrition, if consuming these kinds of products.
Okay, so you are asking how the companies could be regulated, or how they could be, or do the regulations apply to the companies so that they don't get too much profit?
Yeah, precisely. Yes, that's the
Okay.
question. Yeah, that's my question.
Well, yes, okay. I understand what you mean, but and that is something we often hear from public health perspectives. I think we have to be somewhat realistic. there's no company that would be alive if they had bad food or food that is killing you. And regulations do also look at what they have to do. I don't know how much the regulations would vary from different jurisdictions across the different jurisdictions. But in what I think and know is that there's no jurisdictions that would allow food to be sold as killing people and so on. We have, I don't know what would be the way of getting profits because every company would have pretty much similar raw material costs. And the raw material costs often are quite substantial. And then if you go to marketing, and if you go to wholesale, and then you go to minute sale and so on, usually the share of the company is very tiny compared to, let's say, the marketers and so on. So we should first define where is the different shares going. And I think we don't really have in the food area too much opportunities to make huge profits. Of course, the company sizes may increase and they may be global, and little penny uh, becomes bigger penny for the whole company. But it doesn't mean that it's only making profit on the expense of the health of people. They are very responsible companies. So that's what I think that we have the regulators and we have the companies, and no company is existing if it cannot uh, cover costs. And then we have other players. Yes, that's what I think.
Thank you, Professor Roos. So with this last question, I think we are ready to close this session. Thank you, everybody, for joining us today. Thank you so much, Professor Roos, for this very interesting talk and very controversial, but very needed. Thank you, everybody. Keep tuned, please, and check our webpage and Facebook and Instagram accounts and our YouTube channel for this for the recording of this interesting talk.
And of
Thank you,
course,
Professor Roos.
if I may say, I say thank
Sure.
you as well. But also, if anyone wants to contact directly me, they can find my email easily and be in touch. Thank you very much for everyone.
Thank you so much. See you, everybody.
Bye-bye.
I'll email you and Professor Roos. Thanks so much.
Thank you. Bye-bye.